Hey guys, it's Keanu again. It's just kind of late here, but I just felt like doing another one of these. This is going to be my third video. So obviously, as you can see on the board, I'm doing acceleration. So the formula for acceleration is acceleration equals change in velocity over t. So this triangle is called delta. Oops. Which is the change in blah blah blah. In this instance, is the change in velocity. Okay? So acceleration is something accelerating, something changing speed. Change in velocity, change in speed. This can also be written as acceleration as a vector, so it has a direction, equals delta v, so velocity, so it has a direction, over t. As well, this can also be written as acceleration equals vf minus vi over t. Or if you don't want to use vf or vi, you can use v1 and v2. Well, actually that would be v1, that would be v2. That just says, okay, this is my final velocity, this is my initial velocity. The difference between the two is my change in velocity. So you have one minus the other, and then divided by time. And you would always go velocity minus initial, or final minus initial. As well, like I said, you can also do v2 minus v1 over t. It also works that way as well. That is very common, it works very well. There's definitely no problem whatsoever with writing it that way. And actually, for some people, writing it this way works better. It just works better for them. They just figure out the change in, or they figure out the change in the velocity, and then do this part. So which means you could actually apply the magic triangle to it. That is a possibility. The magic triangle that I told you about in my first video, my first one. The speed and velocity. So, in terms of this, I will use the long form just because if you use just this and you figure out delta v on its own and then use this whole equation, it does work as well, but you should also know how to be able to manipulate this whole equation while it's in long form. So I'll start with that. Acceleration equals, I like using vf minus vi over t. If you remember Bedness from probably grade 7 or 8 or something, I remember from 7, it's brackets, exponents, well, yeah, whatever, I don't really care. So, but brackets is important. So which means to do this, you can't just add v initial to this side. What you first have to do would then be multiply by time. And multiply by time. Time cancels. You then, from there, say you were looking for time, you can then divide by the acceleration. Say you're looking for v final, you can just add the v initial. Say you're looking for v final, v initial, you can actually add the v initial to this side and then subtract the TA to this side. That one is a bit more confusing. Or as well, you can just subtract the TF or the VF to this side and divide everything by the negative to make this positive. All your choice. It's very easy to simplify once you get the hang of it. The point of me explaining the beginnings of this is just so you know how to manipulate it. Different ways. And if you have any questions, remember to leave a comment. I will always, always, always check my comments on these things. Obviously right now I only have a couple of commenters, so I'll always check these. Anyways, so I'm going to do some questions now. Okay. Transit bus traveling at 15 meters per second north applies its brakes and stops in 3.0 seconds. What is the acceleration of the bus? Okay, so obviously, what is the acceleration of the bus? So which means we can just go acceleration, actually sorry, most times I just use a lowercase a equals VF minus VI over T. So where do we go from here? Well, what I always like to do whenever I'm really confused is list out my variables. So obviously my A is what I'm searching for. So what about A? My V final, a bus traveling 15 meters per second applies its brakes and stops, which means it comes to rest, which means your final velocity equals 0 meters per second. Your velocity initial equals 15 meters per second. It's also north, so it's a positive number. That is something I believe I stuck in something. Actually, I'm recording this one before my my second video. My oh my god, so stupid. My whatever the second video is. I'll be recording this, so I'll explain that to you in the second video if you ever have a question about that. Then I'm looking for time. Well, time equals, it stops in 3.0 seconds. 3.0 seconds, obviously. I'm looking for acceleration. Acceleration is right there. I can plug everything right into my equation. You then get 0 meters per second minus 15 meters per second divided by time, then equal negative 15 meters per second over 3.0 seconds. 3.0 seconds equals negative 5.0 meters per second squared. Acceleration will that is the normal units for acceleration. I actually should have explained that earlier. Your normal units for acceleration is always, will most times be meters per second squared. That is very normal. That is what I usually ran into in terms of, so like gravity. We have constant gravity here on Earth, which is 9.81 meters per second squared. Negative 9.81 meters per second squared, because it's dragging us towards the Earth. So it's negative, pulling us down. That is constant gravity here on Earth, unless something says otherwise. If you get a question otherwise, make sure to follow the question. Do not use this. But use this if it doesn't say anything. If you happen to, or if you know how to use acceleration, and you can use this and it should work, do it. But if you know a better way, an easier way, use that. Anyways, so this, in my, actually I didn't really explain this in my first video, I meant to explain this. So this is part of a vector. It's a negative. This sorry, never mind. I keep forgetting what I'm gonna do next video. So since this is negative, this also means this is an acceleration of 5.0 meters per second squared. Since it's south, or since it's north, and it's slowing down, that means it's accelerating backwards, which means it's accelerating 5.0 meters per second south. That is always how we write the vectors. There we go. That's a question right there. Sorry, I was just checking the time. That's probably why my voice got really close. Okay. Hopefully you guys understood that. These are all questions I got when I was in grade 10. So, anyways, yeah. So that's 2. Oh. Never mind, I just needed the acceleration. I didn't have to put in the vector direction. Anyways, I'll start this. An object starts from rest and accelerates at 1.3 meters per second squared north for 6 seconds. What is the final velocity? So obviously, another straight one was the final velocity. Okay, so we know velocity final, we don't know. We know velocity initial, it starts from rest. Initial velocity equals 0 meters per second. We know accelerates at 1.30 meters per second squared north. Acceleration equals 1.30 meters per second squared. Yeah. And we know time for 6 seconds. 6.00 seconds. Okay, so now we can integrate equals Vf minus Vi over T. So to do this, so we're finding Vf. So what we need to do, and this is another very easy one, multiply both sides by T to get rid of the T's on this side. Then we can just add Vi to both sides, because you have a minus Vi plus Vi, they cancel. You then get velocity final equals Ta plus Vi. And there we just plug in our numbers. 6.00 seconds times acceleration 1.30 meters per second squared. I'm running out of room here. Plus 0 meters per second, because velocity initial is 0. Another thing, you can also realize that here and just be like, oh, hey, there's nothing. It's 0. It's not going to change anything. So which then means I can then go 6 times 1.3. 6 times 1.3. Yeah. So which now means I get 7.80 meters per second. So in my video 2, I did explain, or will have explained, or I keep forgetting that I haven't done it yet, 7.8 meters per second. So in my last video, I will have done an explanation of significant digits. So I go by lowest. So lowest, since I'm multiplying, I am using lowest number of digits, of significant digits. This has 1, 2, 3. This has 1, 2, 3. Those are the only numbers I have. So I automatically have to have 1, 1, 2, 3 significant digits. So right there is my final answer. Oh, sorry, never mind. One more thing. Is accelerating north from rest, which means this is a positive number, which means it is north. Extending brightness. There we go. Okay. So since it's accelerating north, you know that this number is going north. Whatever this object is going 7.8 meters per second north. So not bad. I'm probably completely confusing you with the whole change in things. That was not what I meant to say. Whatever. Anyways. So this will be my final question. What is the acceleration of a ball that slows down from 5.0 meters east to 2.0 meters east in 6.0 seconds? So, obviously, looking for acceleration again. On every single piece of paper I use for all these questions, you're always going to see like a little black thing here. That's because my grade 10 teacher was awesome and gave us the answers so we would know if we got it right or not. That's why I blacked this out, because, or maybe I shouldn't. Tell me guys that if you guys want to keep seeing that or not. Most of my teachers always did that, was give us the answer so we knew it. Anyways, so obviously I'm looking for acceleration, so acceleration we don't know. Slows down from the initial equals 5.0 meters per second. V final equals 2.0 meters per second. And time equals 6.0 seconds. Tell me if I'm going too fast. Acceleration equals V, oh my god, I'm going too fast for myself now. Vf minus Vi over t. Obviously, acceleration is what we're looking for, so I can just plug everything in. Vf 2.0 meters per second minus 5.0 meters per second over 6.0 seconds. All of this has two significant digits, so I can just go equals negative 3.0 meters per second over 6.0 seconds equals 0.50, because this is not a significant digit. This is a placeholder. It is not a significant digit. 0.50 meters per second squared. West. Because since it is slowing down, it's going east, and it's slowing down, then we know that it's slowing down. Then we know that it's accelerating west. Anyways, yeah, so that's our final answer. Leave comments if you guys want me to do other videos of anything I didn't explain. Leave comments. I will respond and try and answer any questions you guys have as best I can. And yeah, always remember, don't forget to be awesome. And thanks for watching. Hope you guys learned something new. Bye for now.